So thanks for having me. Yeah, like I just said, I'm Phil. I'm one of the 45 Brazilians you probably met during this conference. Asking, is this like a soccer thing? What's going on? But the reason that I was invited, to have the privilege to address you this early morning today, 9 a.m. is early for me, is that I have spent the last 3 years about working kind of deeply into product building with generative AI. And one of the things that we've learned, or many of the things that we've learned during this process became a series of articles that then got to presentations of various different things. And something I've learned over the last 3 years, producing content and giving talks and all that kind of stuff about AI is that it's kind of hard to address a wide audience, like the diverse audience, like in a conference like this, because different people coming from different perspectives, from different levels of experience. So I will take advantage of the fact that this is supposed to be a keynote and kind of set the scene. And I'll try to focus a little bit on, basically what you need to know is a little bit of architecture, a little bit of AI, and what you don't know from one side or another. Hopefully, I'm going to give you pointers that you can look up, some good homework for y'all. And I have enough, articles and other things that can help understand a topic that might be a little on the blind spot a little bit. All right, so with that, did it move? Oh, the first thing is, I hate when presentations have like, who am I kind of slides, because, it's like, oh, why you should listen to me? This one's kind of the other way around. It's like, why you should take what I'm saying with a grain of salt. The reason you should do that is because although I've, been in this journey for a fair long time compared to how nascent GenAI is, I have my own biases. I've been building software in a very specific way for 30 years. I've been, successfully built some teams and some architectures really on like microservices, distributed systems, all that kind of stuff. And that's what I'm bringing to this world. If I had a data science background or an AI research background, probably I would have different opinions and different things to say. But basically, to me, the way this manifests itself is that I'm very biased towards actually getting stuff done. I'm very, very biased towards iterative. I'm an old school agile person, like from the 2000s. I want to see iterative incremental development in everything I do. And I don't think the AI gets a pass out of this conversation. So, bias beware, because like that's the kind of bias that I have. But before we go into details on the architecture, I want to talk a little bit about what was that we're building Ultrapy. So I've been an engineer for, like I said, 25 years now. And over time, I started managing teams, leading teams, and doing the kind of management leadership work, tech lead, manager, CTO, director, kind of played all these roles at different organizations. And one thing I always found is that when I'm working on code, I have VS Code, IntelliJ, Eclipse, whatever IDE you might use. They have all these automations, refactors, different things. You make your life much easier and allow you to work in much larger code bases. When I'm working on the leadership, kind of my leadership brain, my leadership role, there's basically nothing. There's a bunch of Google spreadsheets somebody gives you. I'm pretty sure anybody here who has been to more than 2 or 3 positions as a manager or a director has a Google Drive folder full of templates and checklists and things that you carry from job to job that are like applying. So my initial idea back in 2021 was like, okay, can we automate this? Can I create basically the VS Code for everything that a manager does, or everything that an engineer does that's not just writing code? We basically started building this the moment generative AI became a thing. It took about 6 months to get to the first release, or to like the first public beta. Back then, we were using ChatGPT 2.5. Eventually, we were using GPT-4. It was a little too expensive. We're like a small company, so we had to limit how we use that, and we learned a lot from that, and the various flavors of Llama models that were being released. And we started as a Slack chatbot. Eventually, we became like a Google Chrome extension. This is a screenshot from our pitch deck that shows the Chrome extension. And one of the interesting things about Ultrapy itself, it's a very kind of garden variety AI startup, but we were so early that we're one of the few actual companies to reach like a few thousand people actually using the application when everybody else is just like doing demos and things like that. So we've been playing this game for quite a while. The problem with I described here almost a very weak pitch deck, but the problem is that this is 2022, 2023, 2024, early 24, so we're up against everybody. Everybody was releasing a similar tool. Microsoft had, I don't know how many versions of Copilot. Salesforce is still trying to figure out Agentforce, Salesforce, whatever they're releasing this week. And that's the kind of stuff that we had. Like the first screenshot here was May 2023, Microsoft Salesforce says, we're releasing this thing, Slack GPT is gonna be awesome. And then every 3 months or so, they would make an announcement. It's like, it's totally coming, it's gonna be awesome. Here's a video that's a conceptual video of what it's gonna look like. And if you work for startups and if you fundraised, especially in the very early stages, you know that every time they kind of had an announcement like this, our investors and our customers were like, oh, Salesforce is gonna destroy you guys. You know, it's like, why even trying? Have you seen Slack AI? I mean, the video is amazing. Of course, it's a conceptual video that doesn't really exist, but it's awesome. Eventually, they released it I think it was Valentine's Day 2024. I remember because I was going to get some flowers for my partner, and then I was like also on the phone trying to, can I install this? Can I try it out? And one thing that was really surprising to me was that the product that we had built, if you use Slack AI, and I know it's a little vague if you didn't, but basically, the product we built was kind of miles ahead in terms of quality than Slack AI. Of course, based on my own benchmarks. But we published a few articles around this with more data that I'm happy to share. But the point was that I started not understanding why Salesforce, such a big company with a lot of people, a lot of money, access to the same technology or better, was struggling building AI products. And honestly, you can replace Salesforce there with Google, even more kind of indie platforms. Most AI products we're using right now, it's the summary of my email that gets everything wrong, hallucinates the stuff. The status quo was terrible and it's still not good. And something interesting to us was that we were focusing on the engineering leader, right? That was our ICP, our customer, the people we're talking to. And we were growing like crazy. We were adding, for such a small startup with no marketing budget, we're adding like a lot of people, new organizations. People kind of, it's a little weird because we were a very small startup and people were like plugging us to their sensitive data and we have to like, please don't do that. But then we realized why it was such. First thing is that I have to be clear that this is kind of a post-mortem. This product failed miserably. But the reason it failed was really interesting, or one of the reasons, or one of the things we saw as we were failing was really interesting, was that the users were not really interested in the tool as much. When we would talk to them, say, hey, can you give feedback on this thing that you've been using? We realized that they were actually using our tool because they were trying to reverse engineer how the hell we were building this. Basically, the conversation we had, this is almost of a verbatim quote, is like, how can two guys and a dog, and the dog is not even doing any work, how can you build like this system that has all this agentic behavior? And we didn't even call agents back then. It was like more the co-pilot kind of verbiage. And I have 9 people, data scientists in the corner, and now we have is a chatbot that tells you to eat rocks. And this is something that I spent a lot of time thinking about and working on. And we produce a lot of content, as I mentioned. There's a lot of different articles that go into details and a lot of different things that I'm going to talk about here. But over time, I've been kind of developing a theory of why these things suck. Why most AI products, especially in the productivity space, are just not good. And I think it has to do with how these products are built. So the way I see it, there's basically 3 ways that we build AI today. And you might see this in your company or across the ecosystem. The first one is Twitter-driven development, which is that whole, this changes the game. Now everything has changed. You're so cooked, man. OpenAI releases this thing, your startup is not gonna make it. And this is a very prevalent mindset among a lot of different people where it feels like they're always building for the new version of the models that are gonna come next year, or that was promised to come next year, or whatever it is. They're not really worried about the current limitations of technology, because Sam Altman said that we're totally gonna get AGI next year. So like, what's the point? I'm gonna build for the future. In fact, Sam Altman said this multiple times, that you should build for the future where OpenAI dominates everything. There's a lot of people building software like this, products like this. And I think that kind of gets to a point to have the flashy, fantastic demos that sometimes get funded by hundreds of millions of dollars, but don't really deliver as much because they're not dealing with reality. On the more kind of realistic side of things, you have another option, which is very, very common in existing companies, less so in startups, which is this is basically a data science project. Now, I've managed, I'm not a data scientist, like I mentioned. I'm a software engineer, back-end, through and through. But I've managed a lot of data science teams over the years at SoundCloud, DigitalOcean, SeaGeek, and others. And one thing that's interesting about the way the data science teams work is that they usually tend to treat project by project as its own thing. They don't, it's less product thinking and more project thinking. I remember when we were building classifiers and recommenders at SoundCloud, it would take 1 year, it's like, hey, can we have a spam classifier? A team would go off, I would fund this team, it would be 8 people, 1 year figuring out what to do. If you're old school data science, Enron emails was what we used to use back then. And then they'll come back after that period of time, and it's like, great, we have a classifier. Okay, cool, what's the success rate? Oh, you can detect 50% of spam. It's like, wait, what? So you're telling me that I just invested eight people for 1 year time to get something that's just as good as flipping a coin? That's kind of not great. But don't worry, we have this new technique. We are going to build these new advancements. It's going to be much better. We just need like 10 months. And they go again for 10 months, and they get something that's like 50%, 55%. I'm exaggerating, obviously, but let's say 55% good at classifying spam. And at the same time, they wrote 5 different research papers because this technique is really novel. So that kind of slow, incremental things is how data science usually builds stuff. And that's one of the things that we see in the AI a lot. I know a lot of different companies that are building the AI product that was announced sometimes on an earnings call by some CEO, some fancy CEO, but they have 10 people in a lab kind of fiddling with models, trying different things, trying different techniques, whatever was out on Hacker News yesterday, they're trying today, trying to get to this system into a product. And it's taking too long, it's not going well, the classic story, very kind of waterfall. So I don't think that this approach works well for products for one reason. When we're doing this for data science, I didn't have my spam classifier. I had other things that I could do. I had both humans labeling data. I have user self-reporting when something was a spam, all this different kind of stuff. When we're talking about AI and generative AI in 2025, what we're talking about is putting the AI right on the critical path for your project or for your product. And when that critical path for the product depends on this, when basically how much your company is worth depends on that, you can't take this approach that takes 1-2 years to get something done. And then there's the third approach that you might have guessed is the one I prefer. Again, back to my biases, which is basically treat these as engineering projects. And the way I see this is very the way that we do the classic from skateboard to spaceship kind of iterative development. And that's how we built the system that, the tool that eventually became Ultra-P. And I think there's a lot of interesting things that can be done that way. Things are a little harder. But one of the biggest blockers people find when trying to apply software engineering approach and product engineering approach to AI is that there's a lot of things in AI that are just not a good match for the technology, especially that we built for software engineering. And I think there's merit to this. There's things that need to change. But the situation is not as dire as we might think. And that's one of the things that I want to discuss a little bit further. So first, now that there's a lot of context, but let's think about building blocks. Different people use different words for different things in AI. And I want to kind of establish as a vocabulary for the rest of the talk that there's basically 2 objects or entities within an AI and generative AI system. There's workflows and agents. Workflows, if you read anything I wrote before, I used to call them inference pipelines. I still prefer the term inference pipelines, but Anthropic called them workflows, and I don't have the marketing budget. So I'll just go with workflows for now. Very confusing, terrible name. But anyway, a workflow is basically a predefined kind of set of steps to achieve a goal with AI. Summarize this email. It's like, okay, go here, there, boom, done. Or recommend me something. The different things that we do with AI, but it's a static pipeline. And agents, it's interesting because nobody has any idea what the hell an agent is. But the way that we've been kind of going about it is, I like this definition where systems where LLMs dynamically direct their own processes, tool usage, blah, blah, blah. So basically, it's a piece of software that has a semi-autonomous. It can make decisions. It can it can collaborate with other things. Some of these things are tools. Some of these things are other agents. And it basically executes tasks on its own. It's given a goal, and it goes and does that. So with these two kind of broad concepts, and we're going to dig deeper on them. But the first thing you see is that when you talk about workflows, if you talk to a vendor, especially a RAG vendor, RAG is retrieval augmented generation. Basically, it means, the summary of RAG is, I'm going to put context into your prompt so that the LLM know about you, your problem, your company, whatever it is that it needs to know to solve a particular problem. There's various different ways to do that. There's various different frameworks and ideas around this. But basically, a lot of vendors will sell you this. Like, we're going to get you data from all your data sources. In this case, building on the example for our own tool, we get all the different productivity tools. We're going to send it to a model. We are going to use some kind of vector database. Back then, 2023, vector databases was super hot. Everybody was trying to sell you a vector database. And then you're going to have the data that you need to do what you want. And what we've learned is that this almost never works. This is great for demos that you show your boss and you get funding for the project. But once you start actually building systems, just this one step from A to B is LLMs are not that smart. They were not that smart then, and they're not that smart now. What you need to do usually is kind of add more steps that add more flavor, more color, more structure to what you're doing. In our case, one very typical thing was we processing messages from Slack. And you could say, hey, our first project, our first product, our first feature was a daily briefing that you receive every morning. I could send you all the messages from Slack, say, amongst all these things, please tell me what are the topics that Phil should care about. That was our first beta. It worked very well for the demo, didn't so much for anything else. But the reason that, the way that we evolved that is that instead of doing this, we actually added a step. It's like, hey, this is all messages that happen in Slack within the last 24 hours. Can you break this down into discrete conversations? And tell me what are the topics of these conversations. Oh, and now among these conversations, can we have like individual discussions? Because in Slack, people come and go and a very asynchronous kind of workflow, and build this object model, and that's really a domain model, the same way that we have domain models elsewhere, that then we, as a final step, say, okay, fetch data from this object model, that's structured, that has semantic meaning, with these other contexts, it might be whatever it is, what time of the day. One thing that was really important to us was whatever was in your calendar for the day, and create the summary, the daily briefing for this person. And there's a lot of interesting things around this, especially around caching and other things that you can do. But the most important thing to me is that this was an exercise in actually building, again, a domain model. That's what we were doing. We're building multiple different slices, bounded context, whatever you want to call, using the LLM to do the transformation. So don't fall for the usual thing. In fact, this is actually one of the basic workflows we had. This is screenshots from our internal systems. That actually generates the daily briefing. I think that's the case. And as you can see, there's like a lot of, each one of these things is basically a step on a pipeline that executes some kind of transformation, takes data in one format, return data in another format. And I said, it's a step in a pipeline because basically, to me, we can create a very, very direct parallel between these workflows and data pipelines. And that's useful because then you can start thinking about the tools that we use for data pipelines already. Do you use Apache Airflow? Could be a good tool for you. Do you use some kind of different data workflow DAG engine? That could be good for you too. So it starts giving you a little more to work with instead of just starting from this kind of mythical world of AI where everything's possible, but also nothing happens. But then it still leaves us with agents. So it's like, okay, what are agents? What are these agents saying? How can I build an agent? What does that look like? How can I model, as a software architect, how can I model an agent? What kind of entity it is? The first thing everybody does when it comes to this agent business is think of them as microservices. And I tell you, don't do that. As somebody who spent way too much time on this microservice stuff, I'm sorry or thank you or you're welcome. I don't know, whatever flavor you might prefer in terms of distributed systems. Agents are actually very, very bad fit for a traditional microservice architecture. Obviously, you can adapt and mix and match and do things, and a lot of people do. Agents are very stateful. This is often terrible for microservices for various different reasons. They're stateful to a point where, because they have memory, they need to basically load everything they know about the user whenever they receive a request from that user. So, and then they have to do that again and again and again. It's a very complicated setup that I don't think is a good match for this. Non-deterministic behavior, the only reason I think microservices even work is because there's not a lot of variance on the paths that one takes within a microservice architecture. You know, of course, we have 10 different combinations of microservices or whatever, 10 million different combinations of microservices. Yeah, but you have that, the number is bound. You introduce a new feature, you have basically a new circuit is designed within your architecture. That's fine, but that's an event that has happened. When it comes to AI, you never know which way around your microservice architecture that request is gonna take. And that will definitely hit you when it comes to operations. Data intensive, poor locality, kind of related to state a little bit, but it's always very hard to fetch data. AI depends on fetching data from disparate sources, and only little chunks here and there. They vary a lot. It's hard to cache. Caching a lot of times don't make sense. So it's like kind of start breaking and underlying external dependencies. A lot of what you're going to do is, you know, the microservices word of I'm calling my database, I'm calling another service, and maybe there's an exception, is turned upside down because you never know what you're going to get back from an LLM. Anyway, this is like the don't do microservices rant. But then, okay, let's kind of go back to that definition, try to get into a few words that summarize what agents are according to this particular version. Agents have memory, so they know, they have understanding of what has happened in the past and how that impacts the future. That's really important for what you're trying to do. They're goal-oriented, so instead of just going step by step like we were doing with the workflow, where each step does a little thing, you should be able to tell the agent, do this thing, and it goes and does that for you. They're dynamic, because depending on what's in the memory and what kind of stimuli it received, it will behave in a different way. And it likes to collaborate. So agents will always, even to be effective, they need to do something in the real world. So that means they will call a tool or they will call the agents, and oftentimes a lot of the combination of this. And then wearing my very biased software engineering hat, when I look at this, it's like, okay, I actually know some systems that, or a paradigm that matches this very well. So we talk about memory, like that sounds like just general state. It's very heavy, but it's general state. Goal-oriented sounds like encapsulation. Sounds like, I'm giving you what, not how, and you're protecting the how. Dynamic, polymorphic, we all know these complicated words with a lot of Y's and C's in the end. That sounds good. And collaboration can be a version of message passing, can be other things as well. The reason that this is useful to me is because it allows me to start thinking of agents more like the way that we always thought about objects in object-oriented programming. And again, I wouldn't claim that this is anywhere close to the correct definition that some particular lab or source of AI information would tell you, but as an engineer, this is really helpful to me because this helps me build systems with these things. I can start thinking of them, and maybe my thinking will evolve past that, but it gives me a starting point. I know how to build objects, and I can work this way. So basically, in the toolkit that we build, we started thinking of workflows as basically data pipelines, and agents are a lot like objects, and with the good and the bad side of it. So now, from this, let's talk about a few of the architecture pointers. And I'm going to go over a few kind of hot takes on the things that we built. But there's a lot more information online if any of this is interesting or something you want to follow up. Otherwise, I'm also here for the rest of the conference. So the first thing, we talk a lot about agents collaborating. What I'm going to tell you is avoid point-to-point agent collaboration. It's funny because I just told you the agents are objects, and that's how objects work, right? Like your object A called object B. That's when my kind of whole framework breaks down a little bit. Because usually you start coupling all these different kind of agents to each other in a way that it's even worse than you have an object-oriented system, because the agents are autonomous and they make decisions on their own. But this is like philosophical, where I can like discuss a lot of software quality measures of this. But also another thing that's really weird with agents is that because of the way they kind of float in the ether, it's very easy for you to end up reinventing like WS star, SOAP, and all this kind of stuff. Why? Because you're going to start thinking about, oh, I need a directory for my agents. I need some discoverability way. Or what if an agent doesn't know that another agent, that another agent has changed information? What happens then? How can they negotiate this? How can they do security? And I've seen a lot of people start basically rebuilding what we used to do with XML back 20 years ago, but with JSON, because that's, I guess, better somehow. And basically we invented the classic web services stack in this environment. So avoid that is my take. And then, okay, but if I avoid an agent calling another one directly, what do? There's one particular paradigm that I think works very well, which is basically using semantic events. So there's different definitions of semantic events, but to me, the reason I like to say semantic events, because a lot of times companies have some kind of bus where you tap into some binlog, MySQL, Postgres, or whatever, where you have a lot of crude events. This row was deleted, this row was updated. This uses for this, and Postgres is like a whole stream process, stream project. DynamoDB has one as well. I think every database has something like that. But I don't like to use that when it comes to different systems that are semi-independent. And that's agents, that's microservices, that's everything. I think this kind of stuff needs to be a proper entity. It needs to be a proper object. So instead of saying table users had a row added to it, like, no, there's a create event user that has some structure. There's a schema that's well-defined, well-known, all this kind of stuff. And then that's the kind of thing that you can post into a bus. When I say bus these days, most people think about Kafka. I do not recommend you start with Kafka. I recommend you delay using Kafka as much as you possibly can. Sometimes, if you're successful, you probably will have to touch Kafka at some point. But to give an example, what we were doing, we were following this architecture, was using Redis. Actually, we were doing Python. We're using first this SQL Alchemy, which is Python's most popular ORM system, has its own kind of event system. We started using that all in memory. Then we moved to using Redis, which a lot of people do. And eventually, we started moving to Kafka after we hit some barriers with that. But basically, you send message to this bus, and agents register itself and say, I'm interested in this and this and these kinds of events. And it's a very kind of traditional architecture for messaging that works a lot. It works well in this sense. And then because I'm talking about agents, and I'm going to do an MCP name drop here for those who are more on LinkedIn than probably you should. MCP is called Model Context Protocol. It's a standard defined by Anthropic about a year ago, I would say. Basically, it's a standard for how systems communicate to each other. It is a complete hot take it or leave it, is if you are a small startup right now working on AI, yes, build on MCP, do MCP interfaces, write blog posts about it, because it's all investors want to know about. Whatever podcast they listened to last week mentioned MCP, and they are really focused on that. If you build an internal product, I would refrain from getting too close to even thinking about building an MCP interface. The protocol is evolving. I was talking about WS star and SOAP. The protocol is evolving, and we've seen this before. I heard from a presentation the other day that MCP exists to solve the problems that you don't know you have yet. I've heard this before. It was called SOAP. And that didn't go very well for anybody. Instead, what eventually we ended up converging towards was like RESTful architectures, protocol buffers, gRPC, which are based on things that we basically developed empirically. We saw them work in production, then we created a protocol on that. So again, hot take, hold your horses if you don't have to. If you're raising money, MCP all the things. MCP or dog, I don't care. Like just MCP everything, you will need that. That's how this market works. It's not fair, it's terrible, but it is what it is. All right, so another part of agents that's very important that we're talking about is agentic memory. So what does that work? What does that mean? It's really interesting because there's different ways to think about it. It's actually a very interesting problem to sit down and try to solve on your own. But basically, you need to keep track of everything that an agent knows about somebody. In our case, there was many different agents, But for example, a user, I need to know, what do I know about user X? Do I know that it's a productivity tool? Do I know that they say that they're not going to be in the office today, so they're probably working from home? Or they're not in the office because they're not working from home because they're sick? All this kind of different information was really useful for the kind of software we were building. And then how you go about building this kind of stuff. The first attempt people make, and there's even products to do that, is basically you list everything that you know about the person in a document. And it might sound that I'm kind of abstracting, but no, that's what people do. They just create a very, very long text document with everything that you know about that person. And then you put this into a vector database. And whenever you have to do something about that user, you do similarity search. You find the facts that you know about that person. And OK, that's, I know that Phil was on vacation or whatever it is. This is how ChatGPT memory works. And if you had kind of some freaky, weird things with ChatGPT, a lot of times because of that, because it knows that you've mentioned your cat. It doesn't know that your cat died. So that's the things that happen on a system like this. And oftentimes, especially for productivity tools, but I guess for any AI product, having no memory is better than having a faulty memory. The person with two watches kind of situation is kind of complicated. But there's a very interesting option within what we know in software engineering that actually works very well. And a lot of people are doing it, we were doing it, which is event sourcing. So basically, the idea is we're already talking about having a bus that has events, and the agent's interested in those events. So what if you actually get this stream of events that you're receiving about the user, and you compact them into some form of representation about what's happening? In our case, we were doing a lot of natural language, and natural language can be complicated, but then we found this format here. It's going to be better on this slide. It's called AMR, Abstract Meaning Representation. I don't necessarily suggest that anybody uses this, but it's an interesting way to think. Basically, is a format that information retrieval people defined a million years ago that breaks sentences and what was said into structures. So this looks like Lisp a little bit, but it has, Bob sends a message. Bob have role, blah, blah, oh, wait. Yeah, like the fact is, the message was sent on Slack. It's hard even for me to read this. Bob sent a message on Slack is a fact that has a structure, could be a JSON payload or whatever it is. And you can start breaking natural language into these facts and kind of creating a log system that you can create a snapshot of whatever it is. The way that we actually use memory was through a graph database. We actually use Neo4j. The main interesting thing about AI that we've seen in other domains is that when especially dealing with natural language, you cannot be super sure about things. So we actually had a probabilistic graph, which is a thing that I've written about, and I can send you pointers. But because if somebody says, hey, this project is late, how do I know if this was the person who manages the project? How do I know if there was an intern who misunderstood something? Or how do I know if the person was joking? So there's like different things that one needs to do that way. But in any case, event source is a great option. If you all know something called Zap, which is, I think they're open source, but also a product. That's also how they do it. They do it in a different way. They do it with pure natural language. I suggest that you don't do your events on pure natural language. You structure them. But event sourcing is definitely a way to go about this. The next one is kind of related to what we were talking about data science in the beginning. A lot of the projects I've seen and I've sponsored in the data science side of things, they create monolithic pipelines. So basically, I want to have a classifier for my content. They will get something that builds from data store A all the way to spitting out the classified content, whatever it was on the other side. And they will, there's some reuse, usually copy and paste, let's be honest. But basically, they'll build this pipeline from A to B. Now, if you read all the stuff about data mesh and all these fantastic things that are totally great and nobody does, there's different ways that you can solve this problem, but that's usually how people work. It's just like this kind of monolithic databases. And that's how we started. I think it's a valid starting point. But then you ended up having basically first the high coupling between each stage. It's very hard. Even copy and pasting things is hard because there's no well-defined interface between each stage. But the worst thing to me was that the pipeline mixes unrelated concerns. And what that means is, in our case, the same pipeline was fetching messages from Slack, and not necessarily the act of fetching from Slack, because that was saved on a in a database. It was more like understanding that Slack has a particular format for how to do mentions, and what's a thread on Slack, and all these different concepts. And it had to understand also how Google Calendar works, just so that it could generate some kind of report in the end. That's like a lot of different concerns in one go. Instead, what we did a lot was basically, again, applying good old software engineering and breaking pipelines down into, or breaking workflows down into smaller ones that actually had some kind of published interface, some kind of actual semantic meaning and semantic entities that they return. In our case, these are members from the actual personalized summary. We had one tiny pipeline that summarized discussion from our Slack channels. Then we would deduplicate discussions because, it turns out that people talk about the same stuff in different channels. We would then rank the discussions in personalized summary. So the interesting thing about something like this is that I can basically swap the first item, the first component there, and say, no, I'm not supporting Slack anymore, or I want to use the same logic, but for, in our case, Discord, or Microsoft Teams, or even email. You could basically reuse the same thing. So we use, obviously, the kind of golden gray of everything we do, but it also allows, and that's an interesting thing about AI in particular, we're talking about agents being dynamic. It allows agents to swap things in and out as they please. This is a more advanced thing that you might not ever do. But if you just think of the concept of agents as a thing, they should be able to do that. They should be able to, actually, I'm not going to re-rank this message. I'm going to send to, or I'm going to choose this re-ranker instead of that re-ranker. That happens a lot. All right. So we talk a little bit about how these things are built, these various different components of an agent to be resilient to a production environment, to a product. But wait, I was talking about agents being objects, and I'm hoping you all understand that it's an analogy that's useful. But there's one interesting problem with objects, which is there's always this guy. Like Martin is always saying something that kind of destroys everything I do. And in this case, it's a very, very old, this is 2004, kind of meme, I would say, around distributed objects. The first law of distributed objects: do not distribute objects. So if I'm telling you these things are like objects and these are distributed systems, like, holy shit, this is okay. Math's not mathing here, what's going on? So the first thing about this, to me, is that context. Whoever was writing software in 2004 knows that this is very much focused on the kind of software we had back then with kind of RMI, distributed objects, Corba, enterprise Java beans, all that kind of stuff, where the kind of call we would make would be user.getName. You wouldn't know if that's a remote call or not. And oftentimes, it was a remote call, and your system would ground to a halt because it was terrible, kind of chatty interfaces. So there's a little bit of an agent's a more coarse-grained object, which is more similar to a component, if you will. But it doesn't really matter that much because there are implications to how we build software, how we deploy software and we operate software in the agentic systems that 2 years ago, when I started this, I would go to an AI meetup, and I would talk to other folks also building these systems, and I would ask them, say, what about these problems? And it was really confusing to them because they were just like deploying to even sometimes a DigitalOcean droplet or some kind of small thing like that. And the problem was that every single thing we built in the last 10 plus years is based on this little document around infrastructure. So if you're not familiar with this, this is a 12-factor app manifesto. This is like late 2000s, early 2010s. Heroku, as part of the really innovation of a product that they did back then, they released a guide on how to write applications that actually scale on Heroku. And everybody in the industry is like, this is pretty reasonable, and maybe we should follow these principles as well. And from containers to Kubernetes to everything basically that we built around infrastructure and cloud infrastructure that's not data science related over the last 15 years have kind of assumed that we can follow at least a big subset of these kind of principles here. AI systems in general, but agentic systems in particular, just break so many of these rules that it kind of becomes useless. So I just flagged some that I think are more intuitive here. Yeah, store configuration environment. Configuration doesn't control your system anymore. Your system is autonomous, semi-autonomous, so it has configuration in itself that changes over time. Execute as one or more stateless process. There's no stateless. We actually need to bring context every time we execute something, and that context is data that's expensive to bring to memory, so we probably want to keep it around. Concurrency. Concurrency is a joke in AI right now. Not only doing things concurrently can be really expensive, and it's getting better, but still expensive. Latency is a killer. And there's one particular thing that happens a lot in complicated AI workflows is that there's always a bottleneck, which is a decision point. We're like, okay, what's the user trying to say? And oftentimes, this is the slowest part of your system, and you cannot actually make that any faster because you need that decision to kind of move on. Disposability, dev product penalty log, blah, blah, blah. There's all these different things that basically break this model completely, which is one other reason that I'd say I wouldn't think of microservices as a good way to deploy agents and AI in general. But, okay, so what should we use then? So I stumbled upon something that's becoming more and more popular, durable workflows. Actually, the reason I started thinking about this was because people I used to work with at DigitalOcean a million years ago actually started using it a lot. DigitalOcean uses temporal. Other folks that I started talking to, like very, very large scale, like I think DoorDash, like some very big players use temporal. I was like, okay, that's interesting. What's a durable workflow? Oh, and by the way, these three here, I try to be kind of comprehensive. The only one I personally have experience is temporal. And the other ones, I'm sure they're nice, but I haven't used them. A durable workflow is basically a way to do all that pipeline in a way that the framework or the runtime takes care of retries, takes care of, and basically all the resilience kind of aspects of it. Retry is a big one, timeouts, all this kind of stuff for you. And it will, if your workflow is interrupted midway, it will actually be able to checkpoint and start from there. Now, how does it do that? Is it magic? It's funny, no, it's doing that by doing the things that the Haskell people have been trying to tell us for years now, which is separate side effects from orchestration code. So in a framework like this, you usually have some piece of code that's just like, this is just orchestration, just data flow, and this is side effect-driven code. The article I wrote more recently has a lot of interesting information on how we use this to build agents around these different primitives. But irrespective, what I see over and over again is that if you are building an AI system, and sometimes even just a data system, you're going to end up reinventing this anyway. If you don't use a framework already, you will kind of get a sidekick on Redis, and then eventually it's like, oh, I need to create jobs, and oh, I need to split my jobs into smaller parts because I need some checkpointing and this and this and that. Everybody ends up reinventing this whole technology. So I would invite you to at least make yourself familiar with that so that when you become a little, the need comes, you can go for it. So as a final step before we go have more coffee, I think that, okay, that's cool, sure. But can we talk about the elephant in the room? Did I say that I served 10,000 users? And this is the final architecture that we had for this product. And I'm going to tell you, I was a consultant for many years, in the 2000s. And one way or another, I ended up in a situation in my career where I often come to companies where they're in the teenage phase. They have product market fit, products going like crazy, they hit a wall because technology doesn't work. And I come in, somebody locks me in a room, it's like, okay, let's talk about the architecture. And I'm going to tell you that if you brought me as a CTO, VP of engineering, whatever, my first day is like, okay, tell me how we build things here. What's the architecture? And you show me something like this. And I'm like, okay, but how many users we have? And you say 10,000. My first immediate reaction would be, I need to fire every single one of these people. Because this is way, way, way overcomplicated. 10,000 people should be able to serve from my laptop in any kind of system. This is insane. What the hell is going on? But hopefully, a little bit of what we talked about kind of explain why this ends up being so complicated. And between the different databases for memory storage, for content storage, between having the semantic bus maybe from the beginning, because now you have these agent things that you shouldn't be calling each other. The whole thing in the bottom there is all about making sure that we have some resilience around, in this case, with the ChatGPT API. It's a little bit better now, but it's not. I would still have a lot of bulkheads between your code and whatever AI model you're calling. So basically, what I'm trying to say is that we definitely need better platforms. I'm not saying that this is where AI is going to be in the future. I hope not. If we still have to do this kind of stuff to build a productivity tool, we are all screwed. Like, this AI stuff is not going to work. But these platforms don't really fully exist right now. There are two things that I think are interesting, but I haven't used them. One of them, I should have a slide for this, and I can give you the names. It's called BAML. BAML is basically an attempt at structuring AI and the way that we build software AI. There's one big problem for me. I'm a big programming language nerd, and I love programming languages. BAML has its own programming language that kind of compiles to whatever, transpiles, I think is the right term, to whatever language you use. I think there's a massive barrier to entry, and I don't know if they're going to be successful that way. But it's good to keep watching those guys. They're smart, and I'm sure they'll find a way to kind of deal with that. And another one is within the Rails space. It's very recent. I think it's like last week. I haven't had a lot of time to dig into, but within the Rails community, the Shopify people, I'm blanking on his name now. Obi Fernandez actually released, also ex-Starworks guy, released some kind of interesting thinking around how to build AI in a structured way within the Rails framework. I've done a lot of work within the Rails side of things on AI, and there's interesting opportunities and a lot of problems. Well, so the TLDR for everything that I'm trying to tell you today is that there's a lot of hype, there's a lot of conversation, there's a lot of different definitions and things like that. And I am not one to come here and say, hey, that's how OpenAI should work. That's how Anthropic should work, or Mistral, whatever. I don't have anywhere close to the right experience to say how to build an AI model, how to train one, how to serve one. Even operating one is something I have very little experience. But what I've observed building products around this for going on 3 years now is that outside the box, it's really not that different from the concepts we always had in software engineering. Surprise, surprise. Folks who are a little older like me here, like, oh yeah, no way, there we go again. But it's actually very important, because the way AI is in this unfortunate position where there's way too much money, and that means that people need to hype up stuff. And there's basically no technical content in a lot of these things. So in absence of somebody telling you, oh, this is how we built these things, and back InfoQ and QCon back in the 2010s when we were all going cloud native, you would go there and you see people talking about how Netflix, which was much smaller, was adopting the cloud. It's like, oh, okay, these guys did this and this and this, and that worked. Twitter would say, oh, we built Finagle, we built this. There would be these hubs of content that were great, and were all based on actual experience and not vendors telling you what you should do. We don't really have this with AI anymore. And for many different reasons, we don't. So what I'm telling you is, one way to go about this when you're building products and not basically running away because you're desperate is to use your software engineering brain, try to find parallels, and don't think that this is anything different from when you first heard of a NoSQL database. And it's like, oh, what does that mean? It's very different. It's a different way. But still a lot of your kind of assumptions and concepts apply. And that's the message I had for you. Thank you. And I don't know if I have time for questions. You do? No? I don't know. I should like it.